So 2.5, this is going to be part 1 notes. We'll do part 2 on Monday. It's a different PDF. So 2.5 part 1. We're going to talk about the fundamental theorem of algebra. So before we talked about if we have something like x to the 5th power, how many solutions would we have?
5.
We'd have 5 solutions or 5 zeros. Remember, zeros are the same thing as solutions. So 5 zeros. Now before it was we could have up to 5 zeros because some of them could be imaginary, so it might be less. But now we're going to talk about complex numbers. So we're getting into the square roots and the imaginary numbers. So now we're going to have exactly 5 answers. So some of them may be imaginary, but each one of those still counts as a real solution, or a solution. May not be real because it's imaginary, but a solution. So we're going to talk about kind of different ways that we can leave our answer. So we're still going to be solving, doing the same thing, but sometimes it's going to ask us to leave our answer in linear factorization, or it'll say complete factorization. So when it says this, it wants it in factored form. So if I had something like x is equal to 5 and x is equal to -4, the linear factorization of it would be x minus whatever number you have for x equals. So x minus 5. And then how would I do the second one? X plus 4 would be minus -4, which would be x plus 4. So it's always x minus the answer. So this would be linear factorization, is writing it in factored form. So we have different examples of each type, I think from 1 to 4 or 5 for our degree and how many solutions would we have. So in A, how many answers would we have here? 1. It's x to the 1st power. We would solve or find the zeros by changing f of x to be 0 and then add 2 to both sides. So x is equal to what?
2.
2. Awesome. For B, we'd change f of x to be 0. How would we solve here? Factor. What are 2 factors of -9 that add to of 9 that add to -6? -3, -3. So we have x minus 3 and x minus 3. So x equals what? 3 and 3. So we technically still have 2 answers here. It repeats, it's the same answer, but we knew that we were going to have 2 answers to start, and these are our 2 answers. It just so happens to be the same. We have multiplicity here, multiples of the same answer. First C, how many solutions are we going to have? 3. How would we solve here? Awesome. We're going to take out the GCF, so we have x, and we're left with x squared plus 4. Can we factor this any more?
Yes.
How?
X squared equals -4. Right?
But are we factoring it? Can this be factored more?
No.
Why not? Because it's not the difference of squares. Difference of squares, it has to be minus. This cannot be factored more, but we can solve. So we'd set each one equal to 0. So x equals 0. That's one of our 3 answers that we said we were going to have. Next, we have x squared plus 4 equals 0. So like Santi said, x squared equals -4. What would we do next to solve? Square root both sides. So what does x equal?
2i.
Just 2i? Plus or minus 2i. Remember, we needed 3 answers. So here we have 0. We have positive 2i and negative 2i. If you forget that plus or minus, you're missing a whole answer, a whole solution. We needed 3. We've got 3. All right. In D, how many answers are we going to have?
5.
5 solutions. So what would we do first to solve? Awesome. We take out the x cubed. And we're left with x squared plus 9. What would we do next? Can we factor it more?
Yes. No.
Can't factor it more, so we'd set both of them equal to 0. So x cubed equals 0. And x squared plus 9 equals 0. So x cubed equals 0. What does x equal?
0.
0. We'd take the cubed root of both sides, and the cubed root of 0 is just 0. But since we had x cubed equals 0, we actually have 3x equals 0. So we've got multiplicity here. But that's 3 of our answers. How many more do we have?
2.
2 more. So let's solve x squared plus 9 equals 0. Subtract 9, move it to the other side. X squared equals negative 9. What do we do next?
Square root both sides.
Square root both sides. So what does x equal?
3i.
Plus or minus 3i. Awesome. So we've got 3 answers here and 2 here. So that gives us our 5 answers that we knew we were going to have. Okay. So next, we're going to be doing the same thing, solving, but there's a couple different ways that we can leave our answers. We're going to talk about that on the next 2 slides. So it says a quadratic factor with no real zeros is said to be prime or irreducible over the reals. So irreducible over the reals, we can't have imaginaries in our answer. So it would be something like this, where it's x squared plus 1, where there's no imaginaries. I'll show you examples on the next couple pages. So looking at A on the next page, it gives us x to the 4th power minus x squared minus 20. It factors the first step for us. We have x squared minus 5 and x squared plus 4. Can we factor either one of these anymore?
No.
No. So we'd set them both equal to 0. And then let's solve. So we get x squared equals 5. What would we do next? Square root both sides. So what does x equal? Plus or minus square root 5. Awesome. Let's do the same thing with the other one. We have x squared equals negative 4. What would we do to solve? Square root. So what does x equal? Plus or minus 2i. Perfect. Now here, if it says irreducible over the rationals, let's say irreducible over the rationals. That means that we don't want any rationals in our answer. Any rationals, any i's, we would have to leave our answer like this. So if we're leaving it in factored form, irreducible over the rationals, we don't want rationals, we don't want square roots, we don't want i's in our answer. So that would just be x squared minus 5 times x squared plus 4. For B, this would be irreducible over the reals, meaning that we only want real answers in our real numbers in our solution. So here we don't put the imaginary ones. So irreducible over the reals, we would put the rationals, but not the imaginary solutions. We leave the imaginary part as just x squared plus 4, kind of the step before we solved it. Now, in completely factored form, that's when each answer gets its own part. So we said that we had x equals plus or minus square root 5 and x equals plus or minus 2i. So we have x plus 5, x plus square root 5, x minus square root 5, x minus 2i, and x plus 5. This is completely factored form where we have all of the factors in their own parentheses. So this is just how we would leave each answer. It's the same question. Each one of these we're factoring the same. We've got the same solutions, the same x equals, but we're just leaving our answer a different way depending on what the instructions tell us. So if it says irreducible over the rationals, we don't want any square roots in our answer. We don't want any i's, just clean numbers. If it's irreducible over the reals, we could take square roots, but we don't want imaginary. Everything has to be real in our solution. And then in completely factored form, each number that we get as an answer gets its own parentheses. I think most of the homework wants the answers left in completely factored form, but just make sure you read the directions. I want to say maybe 1 or 2 says irreducible over the reals. So it's just the step before. You don't want any i's. All right, we've got 4 more examples. So here we want to write the complete linear factors and state the zeros. So let's find our zeros first, and then we can put it in factored form. For number 1, what should we do first? Awesome. We want to take out the GCF, so we're going to take out that x. And we're left with x to the 3rd power plus 3x squared minus 13x minus 15. So when we take out an x, what do we do with that x? Set it equal to 0. So one of our solutions is x equals 0. How many solutions are we going to have here? 4. We're going to have 4 zeros, or 4 solutions. What would we do next to find the other 3 solutions? Can we group? We've got 4 terms, so you can try to group. But remember, when you group, you need to take out GCFs and be left with exactly the same numbers inside the parentheses. It won't work here. So if we can't group, what would we do? Quadratic formula only works when you have x squared. Synthetic division, we're going to do last over first, just like the tests. So factors of our last, factors of 15 would be what?
1, 15, or plus or minus 1, 15, 3, 5.
Awesome. Plus or minus 1, 15, 3, and 5. Over factors of our first, which are just 1. So we're just dealing with whole numbers here. So inside our box, we're going to put 1, 3, negative 13, negative 15. What do you want to try first? Sure, we can try 1. Drop down the 1, multiply 4, 4, negative 9. Does it work? Nope. Let's try 3. So we get 3. This would be 6. This would be 18. Minus 13 is 5. Times 3 is 15. Does it work?
Yeah.
Yeah. So 3 is going to be our answer. I'm going to add that to my solution list. How many more answers do we have left to find now? 2 more. What can we do next?
1x squared plus 6x.
Awesome. 1x squared plus 6x plus 5 equals 0. How could we solve from here? Factor. What are 2 factors of 5 that add to 6? 5 and 1. So x plus 5 and x plus 1. So x equals?
Negative 5 and negative 1.
Negative 5 and negative 1. So we're going to add those to our solution list. So negative 5 and negative 1. Now we're going to write the complete linear factorization. So I'm going to do that down here. So it's always x minus the solution that we have. So I'd have x minus 3. What would come next? I'm going to skip 0. We'll come back to that. What would be next?
X plus 5.
X plus 5 and x plus 1. How do you think I would write 0?
Just x.
Just x. Awesome. It'd be x minus 0, which is just x. So this would be our complete linear factorization. I'm going to say f of x equals this. So these are our zeros. These are the solutions, and this is complete factorization. So it asks for both things. So we needed 2 answers here.
How come put it like that?
How come we put it like the second way?
Yeah.
Because it asks for the complete linear factorization. So that's how it wants it, in factored form. So the WebAssign is going to ask you for the zeros, and it's going to ask you for the complete linear factorization. So it wants it both ways. All right, let's look at 2. What would we do to solve? Synthetic division. We're going to do last over first. How many solutions are we looking for here? 3. So we have last over first. What are factors of our last? Plus or minus? What? 5 and 8?
Yeah.
Yeah. What else? 2, 4. I think that's it. Well, let's start with that. So I'm going to draw my box. Inside the box, we've got 1, negative 7, 2, and 40. What do you want to try first?
2.
Sure, let's try 2. So 2 times 1 would be 2. Negative 5 would be negative 10. Negative 8, does it work? Nope. Let's try something else. Sure, let's try 5. 5 times 5 is 25. Minus 7 would be 18 times 5. It'll be too big.
Try 4.
Let's try 4. So 4 times 1 would be 4. I think I did the math wrong on 5.
Yeah.
I did, but does it work? 5? We'll go back to that one. So -7 plus 4 would be -3, -12, -10, -40. Does it work?
Yeah.
Yeah, 4 works. Doesn't mean that 5 can't work, but we'll find out in a minute. So x equals 4. That's the first answer that we found. How do I find the next 2?
Just factor it.
We can just factor it from here. Since we started with x to the 3rd power, my answer is going to start with x squared minus 3x minus 10. What are 2 factors of -10 add to -3?
-5, +2.
-5 and +2. So we have x minus 5 and x plus 2. So what does x equal?
X equals 5, x equals -2.
5 and -2. Awesome. So 5 does work. I just did the math wrong. 5 and -2. How would we write this in complete factorization?
X minus 4 times x plus 5 times. Oh no, -5.
X minus 5 and x plus 2. Awesome. So this would be our complete factorization and our zeros. All right, let's look at 3. What would we do for number 3? You could, but even easier than that, what could we do?
Factor.
We can factor it. So this is the same thing as saying x squared plus 7x plus 6, but instead it's x to the 4th power. So when we split it up, we just have to be careful. Instead of it being x and x in our parentheses, it's going to be x squared and x squared. Now it only works when you have an even exponent and the middle adds up to be whatever you split it up to. So if we had x to the 3rd power, you wouldn't be able to factor. Do we have 2 factors of 6 that add to 7?
Yeah.
6 and 1. So x squared plus 6 and x squared plus 1. Now let's finish solving. Let's find our zeros. What would we do next?
Set them equal to 0.
Set them equal to 0. So x squared, I'm going to subtract 6 over, so equals -6. And x squared equals -1. What would we do next? Square root both sides. So x equals what?
Plus or minus I square root 6.
Plus or minus I square root 6, perfect. And x equals, let's do the same thing here. What?
1 I.
Just 1i?
Plus or minus.
Plus or minus. We wouldn't put the 1 in front of it because we don't need 1 as a coefficient, but plus or minus I. So here are 4 answers. I'm just going to write it out. You don't have to write them out separately, but just to show you guys, we have I square root 6, negative I square root 6, I, and negative I. Those are the 4 answers that we were looking for. Now let's write it out as complete factors. I'm going to say f of x equals what?
X minus I square root 6.
X minus I square root 6. X plus I square root 6.
X minus I.
X minus I and x plus I. So this would be our complete factorization. Now, if the question said to leave your answer irreducible over the reals, we wouldn't want imaginary numbers in our answer, so we'd have to leave it the step before we got the imaginary numbers. So that would be x squared plus 6 and x squared plus 1. This is irreducible over the reals. Where we only have real numbers in our answer. All right, let's look at 4. What would we do for number 4? Grouping. Grouping actually works here. So we're going to group the first 2, group the second. What's the GCF from the first group?
X squared.
X squared. And we're left with what?
X minus 3.
X minus 3. What's the GCF from the second group?
-2.
negative 2. What are we left with? X minus 3. In order to group them, the insides have to be exactly the same because those are going to go together as an x minus 3, and then the two outsides go together as x squared minus 2. So if you took out your GCFs and your insides didn't end up being exactly the same, you either took out the wrong GCF or you can't group them. So now we'd set this equal to 0. So x minus 3 equals 0, and x squared minus 2 equals 0. So x equals 3. It's one of our answers. How many are we looking for here? 3. So we've got 2 more left to find. So we've got x squared minus 2. I'm going to add 2 to move it to the other side. X squared equals 2. What would we do next? Square root both sides. What do we get? Plus or minus square root 2. Awesome. So this gives us our other two answers. We've got x equals 3, square root 2, and negative square root 2. Now, how would we write that in complete factorization? X. So x minus 3, x minus square root 2, and x plus square root 2. Awesome. So this is our complete factorization. But what if the question said irreducible over the rationals? Awesome. Irreducible over rationals means that we don't want any square roots in our answer. So we would leave it in the one before, so the factored form that we had before. So that is x minus 3 and x squared minus 2. So that's irreducible over the rationals.